Good day everyone, I am Paclejan and today we will illustrate the quadratic inequality. For the objectives, at the end of the lesson, learners should be able to first, differentiate quadratic inequalities from quadratic equations using variety of ways. Second, sketch examples of quadratic inequalities using real-life situations. And third, appreciate the importance of quadratic inequalities by formulating real-life problems. Before we start, let us review the previous topic, which is the quadratic equations. We all know that the idea of the quadratic equation is an equation with a degree of 2 which uses equal sign and can be written in the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers and a is not equal to 0. To totally recall to your mind, I will show you a mathematical sentence and you will identify which are the quadratic equation. Now identify which of the following is a quadratic equation. You can pause the video to answer this activity. Now let's answer. Number 1 is not a quadratic equation. Number 2 is a quadratic equation. Number 3 is quadratic equation. Number 4 is not a quadratic equation, and also number 5 is not a quadratic equation. Number 6 is a quadratic equation. Number 7 is not a quadratic equation, and number 8 is a quadratic equation. In the activity, the mathematical sentences that are not a quadratic equations are the examples of a quadratic inequality. Do you have now an idea what is a quadratic inequality? If not, I will discuss what is a quadratic inequality. A quadratic inequality is a mathematical sentence with a degree of 2 which uses inequality symbol. Quadratic inequality can be written in any of the following forms. First, we have ax squared plus bx plus c is greater than 0. Second, ex squared plus bx plus c is less than 0. Third, ex squared plus bx plus c is greater than or equal to 0. And last, ex squared plus bx plus c is less than or equal to 0. Take note that a, b, and c are real numbers but a is not equal to 0. Let us take a look at these examples. In the first column is the example of a quadratic inequality, and in the second column is the example of not a quadratic inequality. A mathematical sentence is a quadratic inequality because it has a highest exponent of 2, or a is not equal to 0, and written in the given forms of a quadratic inequality. While mathematical sentence is not a quadratic inequality if the highest exponent is not 2, or a is equal to 0, or it is not written in the given forms of a quadratic inequality. What if the mathematical sentence is not written in the given forms of a quadratic inequality? How can we determine if it is a quadratic inequality or not? Let's take a look at these examples. Number 1. To determine if it is a quadratic inequality or not, we need to simplify it first. Multiply 2x plus 2 and x plus 1. So we have 2x squared plus 2x plus 2x plus 2 is greater than 0. Then add like terms. So we have 2x squared plus 4x plus 2 is greater than 0. Therefore, the quantity of 2x plus 2 times the quantity of x plus 1 greater than 0 is a quadratic inequality because it has a highest exponent of 2, or a is not equal to 0, and uses inequality symbol. Number 2. Similar to number 1, we need to simplify it first. 2x plus 4x plus 4 is less than or equal to 2x minus 2x minus 4. Add like terms, so we have 6x plus 4 is less than or equal to negative 4. Transpose negative 4 to the left side, so we have 6x plus 4 plus 4 is less than or equal to 0. Then we have 6x plus 8 is less than or equal to 0. Therefore, 2x plus 4x plus 4 is less than or equal to 2x minus 4 is not a quadratic inequality because the highest exponent is 1 or a is equal to 0. Number 3. We don't need to simplify it because it is very obvious that it is not a quadratic inequality because of the equal sign. Now let's apply quadratic inequality in real life situation. For example, the ball is thrown vertically upward with an initial velocity of 64 meters per second. The distance d in meter of the ball from the ground after t seconds is dt is equals to 64t minus 8t squared. Question number 1. At what time t will the ball strike the ground? Question number 2. For what time t is the ball more than 100 meters above the ground? Identify whether each of the following questions in a given situation are a quadratic inequality or not, and explain why it is a quadratic inequality or not a quadratic inequality. In question number 1, to solve the time t when the ball strikes the ground, we will use the equation dt is equal to 64t minus 8t squared. Since the ball strikes the ground, then its distance is equal to 0. So we have 0 is equal to 64t minus 8t squared. The mathematical sentence negative 8t squared plus 64t is equal to 0 is not a quadratic inequality because of the equal sign. In question number 2, we can write it in a mathematical sentence 64t minus 8t squared is greater than 100m since the ball is more than 100 meters above the ground. The mathematical sentence negative 8t squared plus 64t is greater than 100 meters is a quadratic inequality because the highest exponent is 2 or a is not equal to 0 and uses inequality symbol. Another real-life examples involving quadratic inequality. Mr. Jack wants to build a rectangular garden enclosed with a fence. He wants the length of the garden to be 3 meters longer than the width. If the area is greater than, less than, greater than or equal, and less than or equal to 12, help Mr. Jack to express this into mathematical sentences. For the illustration, let width is equals to w and length is equals to w plus 3 since the length is 3 meters longer than the width and the area is equal to a. Note that to solve the area of the rectangle, we need to multiply its length and width. Since the area is equal to the length times width, then we can write the quantity of w plus 3 times w. Number 1, we will multiply the quantity of w plus 3 times w is greater than 12. So we have w squared plus 3w is greater than 12. Transpose 12 to the left side, so we have w squared plus 3w minus 12 is greater than 0. Number 2, similar to number 1, we will multiply the quantity of w plus 3 times w is less than 12, so we have w squared plus 3w minus 12 is less than 0. Number 3, similar to 1 and 2, so we have w squared plus 3w minus 12 is greater than or equal to 0. Number 4, similar to 1, 2, and 3, so we have w squared plus 3w minus 12 is less than or equal to 0. The mathematical sentences are all quadratic inequalities because the highest degree is 2 or a is not equal to 0 and uses inequality symbols or written in the forms of quadratic inequalities. This time, let's test yourself. Your first activity is to find out the differences of quadratic inequalities from quadratic equation. Second activity is to determine whether each mathematical sentence is a quadratic inequality or not and explain why. In third activity, how important is the quadratic inequality in real-life situation. And last, sketch one example of a quadratic inequality using real-life situations. For the summary, a quadratic inequality is a mathematical sentence with a degree of 2 which uses inequality sign and written in the forms ax squared plus bx plus c is greater than 0, or ax squared plus bx plus c is less than 0, or ax squared plus bx plus c is greater than or equal to 0, or ax squared plus bx plus c is less than or equal to 0, where a, b, and c are real numbers but a is not equal to 0. A mathematical sentence is not a quadratic inequality if the highest exponent is not 2 or a is equal to 0 and uses equal sign. If the mathematical sentence is not written in any of the given forms of a quadratic inequality, we need to simplify it first in order as to determine if it is a quadratic inequality or not. And that's all for today. Once again, I am Paclejan. Thank you for watching.